In this module, we'll learn about FTA. That is what? FTA is the second part from our real numbers. Do you remember we had discussed it in our introduction? First part was ADL, that is Euclid's division lemma. Second part was FTA. This means what? Fundamental Theorem of Arithmetic. Correct? Now what does this fundamental theorem say? It is very easy. Again, this you already know, children. We are just going to explore it more. So what is this fundamental theorem? It says that, yes, as you can see, every composite number can be expressed as a product of its primes. That is product of its prime factors. Do you know that? We have been prime factorizing the numbers. We know that, right? We'll just see an example also. But let me complete the definition. As the product of its primes, and this prime factorization is unique apart from the order in which the primes occur. So what is this sign? Just see here. Suppose if I try to prime factorize the number 12. Correct? If you try to find out the prime factors of 12, how do we start? 2. We start with 2. 2 6s are 12. 2 3s are 6. And 3 1s are 3. These are the prime factors. How do we write now? 12 is equal to 2 into 2 into 3. And 2 into 2 we can write it as 2 square into 3. Or if you look at another way of prime factorizing 12, suppose the same number 12, instead of starting with 2, suppose I would have started with 3. Then 3 4s are 12, 2 2s are 4, 2 1s are 2. And again, this 12 would have been 3 into 2 into 2. That is 3 into 2 square is again 2 square into 3. So here also 2 square into 3. Here also 2 square into 3. That is number 12 is expressed as a product. Product means what? Multiplication. Exactly. Product of its primes. And how is this? This is unique. Unique means what? One and only way. 12 can be written as 2 square into 3. 2 square into 3. There is no other method. See, when I started with 2, I got only 2 times 2 and 1 times 3. And when I started with 3 also, I got 1 times 3. And did I get here 3 2s or only 1 2? Something different than this? No. So whenever I prime factorize 12 with any method, start with 2, start with 3, still ultimate answer will be 2 square into 3, 2 square into 3. Similarly, for every composite number, see, for example, if I take 36, 36 would be what? 2 into 2 into 3 into 3, which gives me 2 square into 3 square. Or else 36, if I started with 3, it would have been 3 2 2 3, or 3 3 2 2, or 3 2 3 2. Anyway is correct. But ultimately, each and every time, what is the final answer? The final answer for 36 would remain 2 square into 3 square. No other prime factorization. That is a unique. And this is what FTA says us. That, let me repeat the definition again. The prime factorization of every composite number is unit. Every composite number can be expressed as a product of its primes. And this prime factorization is unique irrespective of the order. Order may change here and there. म्हणजे पहिल्यांदा 2 आला, मग 3 आला, आधी कधीतरी पहिला 3 आला. Some the order may change, but the ultimate answer will never change. So that becomes a unique prime factorization. Now, there are few applications of this FTA. Of course, see children, anything that we are learning, there has to be a purpose behind it, right? There is a learning outcome. There are certain applications. Just we had seen 2 important applications of ADL, expressing of the form, finding the HCF. Likewise, FTA also has got 4 to 5 applications. Mind well children, this exercise 1.2 is very important. I think 7 questions are there. Each question is different. Each question is important. Each question has appeared in the board exams. So we are going to look at it very, very carefully. In this module, we will deal with first two applications, and in the next video, we'll deal with the remaining three applications. Okay? So now, the first question they are going to ask us, the first application over here is finding HCF and LCM of the given integers, maybe 2 or maybe 3 integers using FTA. The second application is verifying the relation HCF into LCM is equal to product of the two integers, that is A into B. We know that our two integers are A and B, where A is bigger than B. So that is the second application. Third application would be finding out the ending digit. We'll discuss it in our due course. Fourth application is about the word problems. Always we know the word problems are important. Let us start with the first. Our example in our book is our exercise 1.2. I'm starting with question number 2. First question, wherein they have asked us to find the HCF and LCM of 26 and 91. Now, dear students, using the FTA, that is the prime factorization, we can prime factorize 26 and 91. In fact, we can prime factorize any given integers. So what is the formula for HCF? See the formula you can see on the screen. The HCF is product of common factors with their smallest powers. Understand very, very carefully. Here we need only the common factors. We need only the common factors and we need their lowest powers. Very quickly, we'll see what is the prime factorization of 26 and 91. So here is the prime factorization for all of you. 26, we can see 2 into 13, 91, 7 into 13. Now, HCF is product of smallest powers of common factors. This is very important two words, smallest and common. First, let me find out. Now, you will always write one below the other. So it becomes easy to find out the common factors. I can see only 13 is common. Correct? Fine. 2 and 7 are not common. So only 13 will be taken. Here also the power of 13 is 1. Nothing means 1. Here also power of 13 is 1. So it is nothing but 13 raised to 1. That is 13. So the HCF comes out to be 13. What is the HCF? Smallest powers of common factors. Correct? And the very second rule is about LCM. Let us see what is LCM. LCM says product of highest powers of all factors. In HCF, there were only common factors with lowest powers. See, HCF is a small number, so we'll reduce it. We'll find only the common factors and that too with smaller powers. LCM is a bigger number, so we'll find all the factors, that too with higher. Now, which are the primes over here? I can see 2, 7, 13. So first I'll write down all the primes. 2, 7, 13. And thereafter, I'll check the larger powers. Unfortunately or fortunately, here the power is only 1, 1, 1 and 1. So 2 raised to 1, 7 raised to 1, 13 raised to 1. So it is 2 into 7 into 13. It would be 13 7s are 91, 91 into 2. Whatever is the answer, you can find out the answer, which gives you 182. So your HCF, what you had found out was 13 and the LCM becomes 182. Let me repeat again. HCF was common factors with smallest powers. LCM is all the factors with highest powers. We are very quickly going to look at two small examples. You will understand it in a better way. So let us suppose over here we have taken two integers a and b. Let a be any integer whose prime factorization is of this sort. 2 cube into 3 into 5 square, and B is 3 square into 5 into 11. Now we have to find out the HCF and LCM. Now, what was our HCF? Smallest powers with common factors. Now let me check. Is 2 common to both? No, 2 is only here. So I cannot take 2 over here. 3 is here, 3 is here. 5 is here, 5 is here. So first I'll take the common factors. 3 into 5. Correct? And now we'll check the lower power. Here the power of 3 is 2. But here the power of 3 is 1. So I'll take 3 raised to 1. Lower out of 2. Here the power of 5 is 1. But here it is 2. Again the lower power is 1 over here. Suppose if I had 5 cube over here, then what I would have taken? Obviously 5 raised to 2, 5 square, because 2 is smaller than 3. Right now let us keep it as it is for our simplification. This is 2, this is raised to 1. So 5 raised to 1. Simply 3 raised to 1 is 3. 5 raised to 1 is 5. 3 into 5, 15 becomes the HCF. And then for the LCM, highest powers of all the factors. Which are the factors? 2, 3, 5, 3, 5 I already got, and 11. So I'll take first write all the factors. I will write 2, I will write 3, I will write 5, I will write 11. Let me check whether all are covered. 2 is covered, 3 is covered, 5 is covered, 3 covered, 5 covered, 11 covered. All factors with higher powers. What is the highest? Okay, 2 is only 1 with the highest power 3. 3 here is 1, here is 2. What should I take? Higher power. Obviously I will take 2. 5 is here 1, here 2. Obviously we will take the power of 5 as 2. Ultimately 11. So this becomes 8 into 9 into 25 into 11. Whatever would be your answer that you can find out, that would become the LCM. Remember, it's a very interesting thing again. HCF means highest common factor. Though the word is highest, it is a factor, hence the number is small. And when I say LCM, least, highest, but we get a small number. Least, we get a very big number. The multiple is always a bigger number. So that is the first part, finding the HCF and LCM. HCF, product of smallest powers of common factors. LCM, product of all factors with higher powers. You are going to write down these definitions, learn them very, very nicely. Accordingly, you will be finding out the HCFs and LCMs. Write down. Right now on your screen, we have seen one more example wherein it is about 12, 15 and 21. You can see what are their common factors. How have we found out the HCF and LCM? You will be doing it on your own. Now, here one more important thing. I'll just take the second example very, very quickly before we stop, before we conclude for this session. See, it is about, in the second example we can see, it is about 17, 23 and 29. If I prime factorize, you can see these three are already prime numbers. They are not composites. 17 is nothing but 1 into 17. 23 is equal to 1 into 23. And 29 is 1 into 29. They cannot be prime factorized. Now how to find the HCF? What is the common factor? No common factor. जिसका कोई नहीं उसका 1 है. Yeah. जिसका कोई नहीं उसका, there is nothing common means at least there is one common. Correct? So yes. So here the HCF would just be 1. If you do not have any factor, still 1 is going to be a factor. So 1 becomes HCF and LCM. Obviously all the factors are, yes, 1 is one of the factors, and then 17, 23 and 29. Simply the product of these three numbers becomes the LCM, because that is what we know, product of all the factors, that too with higher powers. So that's all, children. Right now for this video, it is about finding the HCF and LCM using our FTA. We'll continue our discussion of our FTA with the next examples. You will right now, after this video, write down these definitions, definition of FTA and the method of finding the HCF and LCM using FTA. Thank you.